Hello, my shimmering stars. Today, I, Shora Grover, welcome you all to this amazing platform of PW English. So, students, I welcome you all to your Nexus Batch. And today, we are going to start with our new chapter, that is classification of elements and periodic properties. Yes, students, you heard it right. We are going to start with chapter number 3 of your class 11th standard. So I guess you all are ready. But before that, students, there are 6 important lines which I want you should always remember, before starting the session, before starting your inorganic chemistry. So do listen to it very, very, very carefully. I believe in you. I believe in you. I trust in you. I trust in you. Third one, you are listened to. You are listened to. Fourth, you are cared for. You are cared for. Fifth one is you are important. You are important. And sixth, the most important, you will succeed. So students, these 6 lines are really very important and you should keep this in mind before, initiating this inorganic chemistry. Always remember, students, I will be there for you at each and every point in your life, right? So you are going to prepare for so many important examinations, for upcoming examinations, right? So what are we going to do? How are we going to proceed in this particular session, ma'am? See, before proceeding, before understanding, before learning, always remember that you matter to me a lot. You are important. Really, really very important. So whensoever you feel like today we are not able to get any topic, then what you have to do is you have to write in the comment section that, ma'am, please explain this topic again. And still you are not getting the topic, then write again, ma'am, not able to understand the topic. It won't matter to me if you'll write it 100 times, but it will matter to me if you are not mentioning and if you are suffering from it. So it's better to write it over there and just tell me so that I can repeat the topic. I can explain you again with various methods, various terms, so that it will be able, you will be able to understand it. If you will let me know that you are suffering from a topic, you are not able to get any topic, you are not able to understand something, then you need to tell me. Then I will bring more methods for you to make you easy, right? Make the topic easy for you. So students, always remember this thing. Always remember these 6 important key points which I've just told you right now. So now, before starting this wonderful chapter, ma'am, how are we going to proceed? How basically is inorganic chemistry? Because till now, whatsoever we have heard is about inorganic chemistry, somewhat where we have to cram things, where we have to just, read all kind of theory. How questions are asked, ma'am? How are we going to do? Do we have to summarize each and everything? Or is there anything we can understand also? So let me tell you, so there's so many questions which you all may be thinking. So let me tell you, students, inorganic chemistry is really, really very interesting subject. In physical, we do have numericals. We start to solve numericals. In organic, we have reactions. So we, play with reactions. But in inorganic chemistry, basically, we are understanding about elements, I know that as a chemistry student, each and every one of you have heard about a periodic table. You have seen many of the students, many of your seniors have periodic table at their home, right? Have you seen that? That periodic table, basically when you see that you always say that, are you a chemistry student? Yes. Yes. So what is that periodic table? Till now we have seen a lot of things. We have seen here and there in our environment a lot of compounds. Basically, if you study about organic chemistry, we see a lot of elements, a lot of compounds over there formed from elements and all that stuff. So basically, what are these elements? What is hydrogen, calcium, strontium, barium? Then we are talking about nitrogen, phosphorus, oxygen. How are you able to learn all of them and all of their properties? How people are able to learn their properties? For that, we have made a periodic table. Not we have made, yes, scientists have made the periodic table, but yes, we are understanding that, we are learning it. How we are learning it? By understanding what were the principle that they took while establishing the periodic table. So basically, periodic table, if I'm going to cover in this particular chapter, the whole scenario is based upon periodic table. You are going to understand that so many elements are there, so many elements are there, and how to remember their properties, their physical properties, their chemical properties, we can only get with the help of a summarized section that we are going to get with the help of periodic table. We are going to learn the properties with the help of periodic table by assembling them in groups, in periods. No need to worry, these two new terms, groups and periods, you will be familiar to this while in the upcoming sessions. Yeah, okay. So now let us start this session, students, with a beautiful smile. Let me tell you that how I'm going to make you understand your inorganic chemistry. The very first basic thing that I would always say you, that please read your NCRT while you are doing inorganic chemistry. See, inorganic chemistry basically has a huge importance for NCRT highlights. Basically, when you're preparing for a certain examination, you need to study the NCRT for inorganic. Only for inorganic I'm referring to, because I'm teaching you inorganic. And yes, for that also what I have done is, when I'm going to explain you one topic, I will be bringing over here the NCRT highlight for you all. So I will be explaining you NCRT line to line explanation after explaining the topic to you. So I'm going to do it for here today, okay, after each and every session. But what I want to promise for your from your end is, you have to read NCRT after my explanation also. After covering the session also, you have to once go through the NCRT, right? And if you have, students, any doubt, second promise is, you have to write in the comment section. Okay, you have to mention it over there with your name. You can mention, and you don't have to feel hesitate at all. You don't have to feel shy at all, students. Consider me as your elder sister and just say it over there that, please ma'am, explain it again, and I will do for you. Okay, I will bring some questions, some more interesting ways to explain it to you. Yes, students. So shall we start today's class? How are we going to proceed? We are going to start with various segments, and then we are going to do some questions based upon that segments as well. So bringing you back to your Nexus batch only for 11th standard students. Yes, that means for 11th class chapters we are going to cover this. And the chapter name is basically classification of elements and the periodic properties, students. Yes, and the periodic properties. So this is going to be your lecture number 1. And what are the topics that we are going to cover in this particular session today, students? So the very first topic that we are going to start is the introduction section. Now in introduction section, my very first question, which I which though I've also answered you, in few more seconds before, that why there was a need of periodic table. I have already answered, but yes, we are going to, think about it more. Then the next topic will be about Daubernier's trade. Now, what are these basically? The second, third, and fourth topic over here. These are the ways how the classification started of elements, how elements were classified. See, periodic table is not something which is directly created and provided to you. No. There were various experiments, various scientists came into account and they worked on it, and then they established the modern form of periodic table. But before the modern form of periodic table, we do have established these, classification of elements. By these classification of elements, we got to understand a lot of things. A lot of things. So we are going to first of all start with Daubernier's trade, and then we are going to focus, students, on Newland's law of octave. Then further moving on to the next part, we are going to see about Lothermier's classification. So basically, these are going to be our today's topic, today's target, right, students? Right? Clear, everybody? So shall we start with the very first segment of ours? Are you ready? Take a notebook, take a pen, a pencil. That's it. Nothing else. And do have a water bottle with you, because you need water time to time. You have to stay hydrated. You are studying a very, a very important subject. Also, you are preparing for, some competitive examinations. So you need to take care of your health as well. So let us start with the very first part, that is going to be introduction. Ma'am, who are they? They are your friends, students. Let me introduce you to your chemistry classmates. Who are they, ma'am? So basically, she is calcium and he is barium. So I guess now they are here to welcome you to your Nexus batch, and they will be seen in the classes as well, in the sessions as well. They will be asking you questions and you have to answer them quickly, yeah? Okay. So basically, hello, myself is calcium. She is introducing yourself, and he is barium. So, are you guys ready? They both are ready for the particular session. Are you ready? Okay. So, now let us start with the very first part, that is introduction. Now comes periodic classification. See, why there is a need to classify elements. First of all, before starting this, let me show you how does the periodic table looks, okay? How it look like, so that you get familiar to that term as well. Yes. So students, this is your periodic table. Everybody, are you able to see the periodic table, students? Yes. So this is the periodic table. Now this is the long form of periodic table. So my question was, why there is a need, to study periodic table, or I would say why there was a need to establish this periodic table. Now the answer you very well know, but you need to just, brush up your thoughts and think about it in detail. That, see, there are so many elements. You can clearly observe there are so many elements over here. Now, how can we study about those, one by one? It will take a lot of time. For example, if I start to write the properties of hydrogen, then of lithium, then of beryllium, scandium, vanadium, chromium, manganese, nitrogen, phosphorus, oxygen, carbon, okay, helium, neon, all of that individually, it will take a lot of time. It will consume my lot of time. It will basically, if I'm going to write the physical properties or the chemical properties, they all will exhibit different behaviors, right? So what are we going to do? We are going to establish them in such a way that we can learn it easily, we can understand them about easily, we can research on it easily. Yeah. Now let us take a general example. For example, you are in a school, right, guys? You are in a school. Now in your school, what happens? Basically, you are assigned a particular class based upon your age, based upon your intelligence. Yeah. So basically, there are some students who are, in class first, class second, and you are in class 9th and 10th. Is it, is this any probability that you will be kept in class first or class second? No, no, because based upon your age and your intelligence, you are kept in class 9th and they're kept in class first and second, right? So why it is done so? If I have to distinguish some students in the school and I say that please class 9 students come over here, that means all of their mental abilities, I'm not talking about the understanding power. I'm just talking about their age group or just a scenario so that I can differentiate from the another class of students. So they are provided a particular class. Similar way, elements are classified into particular groups, into particular periods based upon their physical and chemical properties so that we can study them very easily. Yeah. So this is basically the periodic table, students. Clear everyone? Now, I guess now you know why there is a need to study the periodic table, right? So the periodic classification basically is not done directly. The very first periodic classification was done by Dauber, Neers, trade. Now basically Dauber-Nears did the very first classification and he gave its trades. Now what are trades, ma'am? What are trades, ma'am? See, Dauber-Nears trades. Dauber-Near scientist gave this, the very first form of classification, that was Dauber-Nears trades. What is the term trades over here? Can anybody, tell me? Just think about it. Just think about it. Trades. Trades refer to the term three elements. Now, what are these three elements? What are trades? Still not getting, ma'am. See, that means according to Dauber-Near, when he used to classify elements, he classified based upon three elements. How come, ma'am? Can you explain in detail? Let us take some example. You will get automatically. Just understand the word trades here stands for three elements. Okay, now what is Dauber-Near's trades? He arranged similar elements in a group of three elements. When he arranged similar elements, now similar elements refer to as their similar properties, I would say, right? In a group of three elements. Now in a group of three will be referred to as your what? Will be referred to as your trades. Yes, students, let us take a general example. Let us take a general example. That is lithium, that is sodium, that is potassium. First of all, let me tell you on which principle this basically classification works. This basically, classification, if I'll talk about the principle, first of all, let me write over here the rule that what they have stated, or you can say the principle only. Basically, it is that, the atomic mass of middle element is equal to is equal to the arithmetic mean of first and arithmetic mean of atomic mass of first and third element. First and third element. Now, on which principle it is based? It is based on atomic mass. On atomic mass. Always remember, it is based on atomic mass. This is what we are taking as an example. So, see, let us consider that see, lithium basically has mass of 7, and potassium, if I'll talk about, it has mass 39. So, if I have to calculate the mass of sodium, we have to do the arithmetic mean of the first and the third element. So, their mass divided by 2 elements, so divide by 2. This comes out to be how much? 46 divided by 2. This comes out to be 23. So, 23 basically is the mass of the middle element. So basically, this is what is Dauberniers trade. This is what is Dauberniers trait. Atomic mass of second element. Atomic mass of second element. So based upon this principle, based upon the rule and based upon this principle, he arranged elements, right guys? Everybody, first of all, please write it down so that I can show you more elements with such cases. So that I can show you more elements with such cases. I guess everybody has written this. Very good. Now see. Now you can clearly observe it over here that these are the elements. For example, lithium, sodium, potassium. So you can see 7 plus 39 divided by 2 comes out to be 23. So the atomic mass of second comes out to be the arithmetic mean of first and third one. Let us take more examples. Let us take of calcium, strontium and barium. So 40 plus 137 divided by 2, approximately it will come out to be 88. Yet again, one more example of Dauberniers trade. The next one is chlorine, bromine and iodine. So 35.5 plus 127 by 2 comes out to be approximately 80 or 81 something. So it is again following the Dauberniers law of trades. Is it clear, students? But yes, from here we could not, classify or establish about more elements. It was valid only till few elements. Clear, students? Is it clear, students? So this was about Dauberniers trade. So this is what I have already told you. Here you can put a star. According to him, atomic mass of the central element was merely the arithmetic mean of atomic mass of the other two elements. Which are the other two elements? The first and the third one. The first and the third one. Clear, everyone? Yes? Okay. Now, ma'am, let us read it from NCERT highlight. I already told you, whensoever we are covering a single topic, we will be reading it from NCERT. It is really, really very important. I know that many of you may skip from NCERT reading, so that's why I have brought NCERT highlights over here. I will be reading. You can open up your NCERT books, just underline it over there. One more thing. If you don't have your NCERT, just go through the Google and write NCERT PDF and just download it. That's it. Okay, students, so let us read NCERT highlight. The German chemist John Daubernier in early 1800s was the first to consider the idea of trends among the properties of elements. So he was the one who was, who initiated basically to classify elements, to understand about elements, right? Now, by 1829, he noted a similarity among the physical and the chemical properties of several groups of 3 elements. So he saw that three elements show some same kind of property, same kind of physical and chemical property, a group of 3 elements basically, which he referred to as triads, right guys? So in each case, he noticed that the middle element of each of the triads had an atomic weight about halfway between the atomic weight of the other 2, which I have already mentioned you. So I guess now NCERT lines are also clear to you after understanding the topic, students. Very good. Let us start with the next, classification. But after Daubernier, what happened, ma'am? After Daubernier, what happened, ma'am? After Daubernier, there was also one scientist. So the next reported attempt to classify the elements was made by a French geologist, that was AEBD Cancuretis in 1862. Okay. So he arranged the non-elements in the order of increasing atomic weight. Now he also focused upon the atomic weight. It was also based upon the increasing atomic weight. and he made a cylindrical table of elements to display the periodic reoccurrence of the properties. But what happened actually, it was not given much importance at that spot of time, so we didn't study about it. We will not study about it. Okay, it was not given much importance. But yes, you should know after Daubernet who came into attempt. Right? Moving on to the next one came as Newland's law of octave. Now came the scientist Newland. See, basically, he was just, he was basically, when he assigned elements based upon, again, the atomic weight, I would say, he focused upon the musical notes. Musical notes, students, do you like music? Even I do like music. See, have you heard about, the sargam? Sa, re, ga, ma, pa, dha, ni, sa. Yes? So, see, what I'm doing is, I'm starting from sa and I'm ending at sa. See again. Sa, re, ga, ma, pa, dha, ni, sa. Sa is starting from first, and at eighth, again sa is coming. So basically what he did, he placed elements, in the same way. Let me tell you, at the spot of Newland law of octave, octave is 8 word, right? So at that spot of time, noble gases was not discovered, so he didn't mention it over here. If you are just writing the elements directly, for example, if you have learned the periodic table and writing, the noble gases, it will get wrong. So according to him, first element and the eighth element have same properties, just as the musical notes. Sa, re, ga, ma, pa, dha, ni, sa. Sa, sa. So they are getting the same notes. So you can even see that basically, if we are starting from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, then the eighth element is sodium. Then again the eighth element is potassium. So basically these three elements will show same properties. In a similar way, if we are taking this element, it will show property with its eighth element. 1, 2, 3, 4, 5. If it is 1, 2, 3, 4, 5, 6, 7, and 8th. Then again, it is going to start. Then it is the eighth element. But it was only valid till calcium atom. It was only and only valid till calcium atom. So first element and the eighth element will show the similar properties. But yes, it is only valid till calcium atom. So it also failed out. Right, students, let us understand about Newland's law of octave with the help of NCERT highlight that we have with us. Yeah, so the English chemist John Alexander Newland in 1865 propounded the law of octaves. What about law of octaves? He arranged the elements in increasing order of their atomic weight. See, students, sometimes in question you may observe that they are asking you directly the principle. The Daubernet's trade was based upon which principle? Again, atomic weight. The mass, right? Here also it is also based upon atomic weight. If I'll talk about the previous one, it is also based upon the atomic weight, right? So I noted that, now this is important, everybody please put a star over here. Noted that every eighth element had properties similar to the first element. Every eighth element had properties similar to the first element. The relationship was just like every eighth note that resembles the first in octaves of music. Yes. So Newland's law of octave seemed to be true only for elements up to calcium. That's why this is the limitation, I would say. This is basically the limitation, students. So this was about the next one, that was Newland law of octaves. I would request each and everybody of you to please kindly write it down so that we can start with our next classification now. Yes, students? Okay, now comes Luther-Meier's classification. Now comes what, ma'am? Luther-Meier's classification. Now, basically, let me tell you, he plotted a graph. He plotted a graph between what, ma'am? Between atomic volume and atomic mass. So now its principle is based upon atomic volume and atomic mass. Upon what, ma'am? Upon atomic volume and atomic mass. Till now we were focusing, the scientists were only focusing on the atomic weight, but yes, over here The graph is plotted between atomic volume and atomic mass. Atomic volume, students, will be taken on the y-axis, atomic mass on the x-axis. Now, when he plotted the graph, he saw a lot of observations. First of all, let me show you. See, what I want you all to know is, see, what I'm doing is, this is lithium, sodium, potassium, rubidium. So what you can clearly see is that all the alkali metals, all the alkali metals, all the alkali metals are at peak. They are present at the peak. All the alkali metals are present at the peak. I'm talking about the positions over here. Let me draw the graph in detail if you are not able to see it. So the graph basically is like this. Okay, so this is basically the graph, and over here, let me write it. This is lithium, this is sodium, this is potassium, this is rubidium. Let me tell you, all of these are alkali metal, the group 1 elements. Now in the next session you will automatically get to know about it, but yes, let me tell you, all refers to the same group. So alkali metals are present at the peak. The very first observation is seen in this case. What about the next observation, ma'am? What is the next observation? Shall we do the next observation, students? Shall we do that? Okay. Now the next observation that you can clearly observe is your ascending part over here. The ascending part. This is fluorine, this is chlorine, this is bromine. Now this is your ascending. See, I am showing it from blue. Now what is referred to as ascending? That means it is going like this. It is going like this. This is ascending, this is descending. Ascending is increasing, descending is decreasing. So at the ascending curves, all halogens are placed. I don't know whether this color is visible, so I'll write it with light blue as well. Okay, so these are ascending curves. Halogens are placed. Clear, students? At the ascending curves. Now, the next observation that was made at the descending curves. Now, see the descending. See, if you'll see this descending, it is helium. If you'll see this descending, it is your neon. Okay. Wait a second, students. If you'll see the descending curves, if I'm showing you, let us see over here. Here is magnesium, not neon, sorry. Neon is in ascending one. If you'll see the neon is going like this. Yeah, neon is at this one. This point is for neon, so I not mentioned it. Okay. So basically, if you'll see the descending ones, you can clearly observe which are present at the descending. Helium is present over here. Hydrogen is present over here. Lithium basically is present over here. Yeah. So basically, if I'll see it like this, it is basically magnesium, calcium, strontium. These are present at the descending. See, this is the line for magnesium, this is the line for calcium, this is the line for strontium. So all the alkaline earth metals, all the alkaline earth metals lie at the descending curves. And okay, at lower part are your transition elements. Okay. Now students, I am just giving you 2 minutes to write it down, then I'll erase it for you so that you can draw the graph in your notebooks also. Everybody please kindly write it down so that I can erase it and you can clearly write it. Clear, everyone? Is this done? Now I'm erasing this graph over here. You can clearly draw it for your own reference. Yes, everyone. Kindly please draw it so that we can now read it from NCERT as well. Yes, everyone. So that we can read it from NCERT as well. Okay, now comes the observations that I've already mentioned you, but yes, we should read it also. So the very first observation is peak points. Peak points are the points that are present at the top students. The topmost point, right? Peak positions on curve were occupied by most electropositive elements. Now, electropositive elements over here, let me tell you, are your alkali metals only, which I will let you know what are alkali metals, why is the name alkali metals given to you in, in the next session. Okay, one by one, step by step, we will proceed further. So peak positions on curve were occupied by most electropositive elements such as lithium, sodium, potassium, rubidium. Clear? The next point is descending positions were occupied by least electropositive elements. Descending position, alkaline earth metals, for example, beryllium, magnesium, calcium. You can clearly observe the graph also over here. It will be clear. See, beryllium, then is magnesium, then is calcium, then is strontium. Yes? Yes, everyone. Next is ascending positions were occupied by the elements, which are electronegative elements. For example, fluorine, chlorine, bromine, all the halogen atoms that you can see, right? Clear, students, all the halogen atoms. Remember, inert gases were not there. See, in this case, if you will see the very basic thing, that here the last point is all of these which are present are down over here. All of these are present down over here, right? The one which are present down over here are basically provided with the transition metals, and basically are metalloids. See, inert gases they have not mentioned over here, but yes, in the graph you may observe the few points. For example, if you can see, but see over here, they have given the position to electropositive elements, then they have given position to the ascending ones, to the descending ones, and then to the bottom part of the curve was occupied by the transition elements. So see, Lothar-Meyer curve was quite, quite somewhat similar to modern form of periodic table. He gives some few points that were, that played a huge importance in that one. If you'll see the importance over here, it plays a huge importance. But yes, it is based upon atomic volume and atomic weight. It failed due to some, exceptions it had, because it was not able to exactly provide you the position of the inert gases also, right, students? So everybody, please write it down. This was about Lothar-Meyer's classification. Yes, everyone. Shall we move on to the next one? And also, see, it was not able to, establish, the concept about all the elements. It was not valid to all the elements. So now, before starting the question segments, let me give you, a quick, idea about the next one, that is Mendeleev's periodic table. Just an idea. We will study this in the next session, but yes, just an idea let me give you about this Mendeleev periodic table. Say, students, what do you think about Mendeleev periodic table, first of all? What do you think? See, in the case of Mendeleev periodic table, if I talk about over here, students, Mendeleev periodic table was again based on atomic weight or atomic mass, I would say. It was again based on atomic mass, increasing atomic mass. Over here, you will see that they have provided some spaces in the table, okay? Some spaces were kept, based upon the properties. They kept some spaces left so that in future some elements will be discovered. And they kept the name of that spaces as eka, aluminium, eka, aluminium, eka, silicon. So these were the names that were given to the spaces that were present over there. Okay. And yes, students, again, if I'll talk about them, they gave 7 horizontal rows. They gave 7 horizontal rows. Now, I already told you that you will be, familiar with the term rows, columns, periods, groups, all of that stuff. So they basically gave 7 horizontal rows and 8 vertical column. Everybody write each and every point about it, though we are going to understand them in depth only. But yes, you should know, right? Now, the 7 horizontal rows that I'm talking about is basically the periods. And 8 vertical columns that I'm talking about is basically the groups. So this was about Mendeleev periodic table, students. Just a brief introduction, though in detail we will be doing in the next class with the modern form of periodic table. So basically the modern form of periodic table, students, which I have shown you already, with the help of this one. See, let me show you it again. So this was the modern form of periodic table. So in the next class, we are going to understand that how these elements are placed over there only. Why calcium is placed over here only. Why this element is placed over there only. Okay. So basically, we are going to understand this in depth. And also, students, I will be providing to you a trick in order to remember all of these elements in same way as they are placed. So the trick will be very, very interesting based upon a song or a, kind of some lines, a story kind of stuff, so that you can remember it easily. Yes. So students, let me give you an idea about it, the periodic table, because you are automatically seeing it over here. So see, one thing I've already told you, see Lothar-Meyer, if I'll talk about, he's shown you lithium, sodium, potassium, rubidium on the same, the way at the peak point. So yes, see, they have same properties. See, somewhat of the properties, some of the, classifications that held before gave an idea that yes, modern form of periodic table should look like this. But let me tell you, the modern form of periodic table, students, that you're viewing over here is not based upon atomic weight. It is based upon atomic number. Yeah. So we're going to understand this in depth in the next session. No need to worry about it. Now, basically, as you all know, this is your first session. So I wanted, yes, you should know that how we are going to proceed in class. That we are going to cover one topic, then NCERT highlight, then another topic, then NCERT highlight, and then a lot of questions. So shall we start with the question segment? So basically, our calcium is asking barium that, hi barium, let's practice some questions. So barium is saying, yes, I am ready. Are you ready, my shimmering stars? So yes, students, I hope so you are ready. What I will be doing is I will be providing you 2 minutes in each and every question so that you can think and answer properly. Clear, everyone? Okay. So first question, shall we start? I'm going to read the question for you, everybody. First of all, read it by your own. Then I'm going to read it for you all. The question is, whose name is not associated with the development of periodic table? Whose name is not associated with the development of periodic table? With the development of periodic table. Quite easy question. I guess you very well know the answer. So yes, I would say that first of all, try this homework question by your own, because it's easy question. I think everybody knows the answer. Yes. Okay. Next question is, which of the following has firstly organized the elements according to the same trend? So I'm going to count till 10. Tick, tick 1, tick, tick 2, tick, tick 3, tick, tick 4, tick, tick 5, 6, 7, 8, 9, and 10. So the first one to organize the element according to the same trend was Darwin's trade. So let us read the option. It's A, Newland, B, Mendeleev, C, Lothar-Meyer, while D is Dauberneer. So yes, answer is going to be option number D. Okay, students, let us give a quick recap. Okay, Newland was based upon atomic weight. Yes, Newland was based upon atomic weight. Also, Newland gave law of octaves. It gave law of octaves. Let us talk about Mendeleev. Mendeleev we are going to study in the next session though, but it gave about, again, the principle is based upon atomic weight, and he introduced the terms groups and periods also that we are going to study. Yes, but it was, done after the Lothar-Meyer's curve. So let's talk about Lothar-Meyer. He plotted a graph between atomic volume and atomic mass. Atomic volume and atomic mass, students, right? So Dauberneer basically is the first answer because he was the first one to initiate it. Also, Dauberneer gave the law of trades, that the mass of, let me correct it, atomic mass of, second element second element is arithmetic mean of first and third element. Yes, this was Daubonnet straight, so it's a quick revision also with us. So answer over here comes out to be option number D, students. Clear, students? Shall we proceed to the next question? Next question is, John Daubonnet gave the idea of trends among the physical and dash. Now this dash basically is written as A, okay? Of several groups of three elements. Here A refers to A is atomic number, B is atomic mass, C is chemical properties, D is electronic configuration. Now again, 10 seconds for you everybody. Very simple question. No need to pick up your pen as well over here, right? Direct question. So see, John Daubonnet gave the idea of trends among the physical and chemical properties. Do you remember? This is from NCRT highlights. See, now only we have read NCRT lines. See how questions are asked. Now you know how they ask questions, right? Of chemical properties of several groups of three elements. Here A refers to as your chemical properties. They are not asking on which idea it is based on. They're asking about that why are they being classified. They are being classified on the same physical and chemical properties, no? So answer over here comes out to be option number C, students. Clear, everyone? That's great. That's great, students. Let us read the next question. Lothar Meyer plotted the physical properties such as atomic volume, melting point, and dash against atomic weight. Here A refers to A mass, B boiling point, C surface tension, D molecules. So tick tick 1, tick tick 2, tick tick 3, tick tick 4, 5, 6, 7, 8, 9 and 10. So students, let me tell you, he plotted the physical properties such as atomic volume. Though he showed the graph between atomic volume and atomic mass, but yes, he explained the physical properties. So all the physical properties like melting point, boiling point, atomic volume were plotted. So the answer will come out to be boiling point. Answer over here will come out to be boiling point. Clear? Now see, by solving some questions also, you understand a lot of concepts. Yeah, so students do solve each and every question. Clear? Now comes the homework part. Though I've given you first question as a homework, let me bring it over here only. Okay, let me write homework questions on the next slide. So here are some questions for your homework. Now what is your role to do for homework questions? Write your answer in the chat section. In the comment section, not chat section, in the comment section. Clear? You can directly write question 1, option A, B, C, D in such a way, okay? So this is your homework question number first. I'm reading the question again. Whose name is not associated with the development of periodic table? Everybody just write down the question. I'm getting a side so that you can write it down properly. Clear, everyone? Yes, done. Shall I move on to the next question if it is done? Okay, now comes your next question as a homework question. This is your question number 2 as a homework. Let me read it for you all. Lothar Meyer drew a graph showing the relation between A, atomic number and atomic weight, B, atomic number and atomic size, C, atomic weight and atomic volume, while D, atomic weight and atomic size. Clear, students? So this is your second question as a homework. I am getting a side. Everybody please either take a screenshot or just write the answer in the chat section, in the comment section. Done? That's great. Let us see the next question. So this is your last question for today's class. That is question number 3 as a homework. You have to find out the Daubonnet trade over here. You have been provided again with the 4 options. A option is sodium, potassium, rubidium. B is magnesium, sulfur, arsenic. C is chlorine, bromine, iodine. D is phosphorus, sulfur and arsenic. Clear, everybody? Yes? So thank you so much, my dear students, for this wonderful session of yours. Now we shall be meeting in the next class. Now let me give you a quick recap that what are we going to do in the next class. Okay, in the next class, first of all, I will ask you some questions based upon the lecture that we have done today. So basically, there will be a quiz session before starting the second lecture, and then the 5 to 10 minutes questions. After that, we are going to understand the topics. In that understanding of topics, we are going to do tomorrow in the next class, that is Mendeleev's periodic table and modern form of periodic table. Now in modern form of periodic table, again repeating, I will give you a wonderful, a funny trick to remember the complete periodic table. Students, complete periodic table. Yeah, so you can just draw it in any sheet of paper, taking it horizontally. I will make you learn it throughout. Yes. So we are going to practice some more questions in the next session then. Now, students, I shall be meeting you in the next class. I hope so. This was able to, you were able to get all the concepts very easily. This was the first session, so I just took, few, not that much amount of time, because one by one, slow by slow, I will be proceeding the time interval for you, so that you establish a habit of sitting for long hours, right, students? So thank you so much, my dear students. Now we shall be meeting in the next class. Till then, keep smiling, keep learning. Thank you so much and take care.